Hi, Weaver. This is the continuous of discussion related to topic practical maximum and minimum problem solving. So here we have a question. The diagram shows the graph of 3x plus 2y equal 30. As you can see that the line is given, as well as OPQR. OPQR is a rectangle with area A. Like O at origin, it means both x and y coordinate at 0, 0 at point O, and P lies on the x-axis, so it means the coordinate of P are x comma 0, whereas the point R lies on the y-axis, so that means the point R coordinates 0 comma y, and Q has coordinate x comma y lies on the line 3x plus 2y. So it means the line is given, which is 3x plus 2y is equal to 30. So if we try to make y subject, that would be 2y is equal to 30 minus 3x, and as we are looking y, so divide to both sides, that gives us 15 minus 3 over 2x. And remember that we are looking the area, which is equal 15x minus 3 over 2x squared of OPQRS. So OP is the horizontal distance, and whereas OR is the vertical, so that gives us y. It means area is basically OP multiply, as we know that the how to find the area of rectangle length into it. So OP multiply OR, that gives me x into y, and we can replace the value of y from above. That gives us bracket open y. The value of y is 15 minus 3 over 2x, and just multiply x inside, so that gives us 15x minus 3 over 2x squared. So this is the required answer of A part. Next we will move on part B, and in part B, given that x can vary, find the stationary point. So whenever you're looking stationary point, we need to know the derivative. So for part B, I will find out the derivative as well of area 15x minus 3 over 2 x squared with respect to x. So dA over dx gives me 15. The derivative of x is 1, and the derivative of x squared is, we are using power rule concept. Okay, so bring down the power and subtract 1 from the power. That gives us 2x, which is equal 15 minus cancel 2 and 2, so 3x. As this we are looking the point of x at stationary point. So at stationary point, derivative is always 0. Stationary point dA over dx is 0. That means 15 minus 3x equals 0. So 3x is equal to 15, and x is equal to 15 divided by 3, 5. So we will find the area at point x5, which is equal 15 bracket open 5 minus 3 over 2 5 squared, it is equal 75 minus 5, 5 is 25, 25 multiplied by 3, 75 divided by 2, so 37.5, which is equal again 37.5, and it is centimeter square as it is area. So now we will say only the area's maximum or minimum. So if you try to find out the second derivative, which gives us the nature of the determine its nature. So either it is maximum or minimum. So d square a over dx square gives me 0 minus 3 into 1, as we are having minus answer, which is basically less than 0. It means at x is equal to 5, we have maximum area, and that maximum area is 37.5 centimeter square. I hope so it is clear. Next question, PQRS is a rectangle with base length 2p, as we can see that 2p units from P to Q, and area A unit square. The point P and Q lies on the x-axis, Remember that the line OY, the y-axis OY divides PQ exactly two parts. In other words, we can say that it's a line of symmetry. So the distance from O to P is same as the distance from O to Q. We can say that the point, this is the solution of A part. So we are working on A part. Point P, we can say that exactly at P we have, as from 0 to left, it's negative value. So we can consider P comma minus P comma 0, and at Q it is P comma 0, because along x-axis y is always 0. So here we can say comma 0, and the coordinate of Q or P comma 0. Point, as you can see that point S and R lies, PQ lies on the x-axis, and the point R and S lies on the curve, and that curve is y is equal to 9 minus x square given. And they have the same x coordinate as P and Q. It means we can say that the coordinate of S or minus P and comma the y is of course on the curve, so it is 9 minus x squared, and the coordinate of R plus P comma 9 minus x squared. So we can replace the value of x. So required S coordinate would be minus P comma 9 minus P squared, same as for R coordinates P comma 9 minus P squared. So the first thing is, as we are looking the express QR in terms of P. So remember that the QR is vertical distance. So QR is basically equal Y. It represents the vertical distance, and we know the Y coordinate of QR is what? That is equal 9 minus P square. So we write it QR in terms of P. This is the answer of A part. And then we will move on B part. So for B part, we are looking the area. And for area of PQRS, of course, it's look like rectangle. So I will use the concept of PQ and QR. PQ multiply QR. And remember that the PQ distance we know already in the question, which is 2P, bracket open. QR, just now we found in the part A, that one is 9 minus P square. So this is exactly the answer of B part. Now, after this, we can just simplify a little bit further so that it will help us to solve part number C as well. If we multiply 2P inside, it gives me 18P minus 2P cubed. That is the area. And for part C, as we are looking stationary point, if you check carefully, find the value of P in which A has a stationary value. So for stationary value, we need to know derivative as well. So dA with respect to P over dP, that gives me 18 minus 6P squared. So as for stationary point, derivative is equal to 0. So that means 18 minus 6p is equal to 0, and 6p square is equal to 18. So p square is equal to 3. And lastly, we can say that the p is equal to square root of 3. So that value of p, so we find out the value of p. We will see for this value of p, what is the area. So we can say that this is the working for D as P is equal to square root of 3. The area is equal to, I'm replacing here. So 2 square root of 3 bracket open 9 minus square root of 3 whole squared, which gives me 2 square root of 3, 9 minus 3, which is equal 6. So 6 2s are 12. It is 12 square root of 3. So if you find out the second derivative, that means because we are looking to determine its nature, it is maximum or minimum. So the second derivative gives us here minus 12p. if you find out the derivative of second, 18 gives us 0, and this gives us minus 12p. So which is, if whatever the value of p here, as we know that the value of p of square root of 3, so once you replace, you will get answer less than 0. It means this is your maximum area. So at point p equals square root of 3, we will get the area maximum. I hope so it is clear. Thank you for watching.